This webinar is titled Geographic Areas and Concepts for the American Community Survey. I'd like to remind you that today's webinar is being recorded. If you would like to follow along with our webinar today, we have posted the slides online for this webinar, and a recording transcript will be posted on our website within the next few weeks. The slides will be available at the link you see at the bottom of the slide. If you have any objections, or if you have any questions during this webinar, please post them in the chat box, and one of our team members will try their best to respond to you as quickly as possible. And with me today are two geographers from the Geography Division within the Census Bureau, Michael Arthur and Joshua Coots. Instructions for using the Q&A feature during the presentation can be found posted in the chat. Let's now go over today's agenda regarding the American Community Survey, or ACS. In the first part of my presentation, I'll be going over the basics of the ACS, including how the data are collected, the topics included, and the geographies covered. Then I will turn the presentation over to our second presenter, Joshua Coots, who will speak on current geographic topics such as places and county subdivisions and how they are updated throughout the decade. After his presentation, Joshua will turn the presentation over to Michael Arthur, who will speak on geographic products and how they can be used with ACS data. I'll conclude this webinar by covering some resources available on our website for learning more about the ACS and census geography. Starting off with the basics and foundation, the ACS is on the leading edge of survey design, continuous improvement, and data quality. It is the nation's most current, reliable, and accessible data source for local statistics on critical planning topics. The survey samples approximately 3.5 million addresses each year. Typically, these data are collected continuously throughout the year to produce annual social, economic, housing, and demographic estimates. The data collected through ACS is used to distribute more than $675 billion of federal government spending each year. Our estimates, covering more than 40 topics, support more than 300 known federal uses and countless non-federal uses. Examples of some programs that use Census Bureau data to determine funding include Department of Housing and Urban Development, Community Development Block Grant Program, and the Public Housing Capital Fund, and the Department of Transportation, the Highway Planning and Construction, and Federal Transit Formula Grant. The Census Bureau typically releases 3 sets of data estimates in regard to the ACS each year in the form of 1-year and 5-year period data sets, as well as 1-year supplemental estimates. I will discuss these data products in more detail in an upcoming slide. The American Community Survey is part of the decennial census program. It is important to point out how the ACS is different from the census. ACS estimates are based on a sample of the population, whereas the census is based on an official count of the population. Every year, over 3.5 million housing unit addresses are contacted by the Census Bureau to participate in the ACS. The information obtained from the sample is then used to estimate characteristics about the total population in a timely and cost-effective manner. However, these estimates differ from those that would be obtained in a census, where every household in the nation is contacted. This results in an element of uncertainty in the ACS data. As such, ACS estimates include a margin of error, or MOE. The MOE gives us more information about the population by telling us how much the estimate may vary from the true population value. But not to worry, we will talk more about the MOE later in this presentation. What does the ACS collect? The ACS collects information that previously appeared on the census long form, collecting detailed social, economic, housing, and demographic characteristics, whereas the census collects basic demographics via the short form, age, sex, race, Hispanic origin, household relationship, and housing tenure. What is produced? The ACS population and housing characteristics, whereas the Census produces population and housing totals. When is the new data available? The ACS occurs annually, reflecting a period of time over which the data are collected, averaging data for 12 months or 60 months, whereas the census occurs every 10 years and reflects a point in time. Census Day is April 1st. The content collected by the American Community Survey can be grouped into 4 main types of characteristics: social, demographic, economic, and housing. Social characteristics include topics such as education, marital status, fertility, veterans, disability status, place of birth, and others. The American Community Survey also collects basic demographic characteristics such as sex, age, race, and Hispanic origin. This is the same information collected on the decennial census. Economic characteristics such as employment status, income, commuting to work, occupation, industry, health insurance, and others. Housing characteristics include topics such as tenure, information and occupancy about the structure itself, which includes home value, housing costs, including mortgages, taxes and insurance, utilities, plumbing, kitchen facilities, and others. Each question on the ACS is used for federal and state government programs. These topics are used to produce more than 1,000 tables for local communities. The ACS provides data for more geographies on an annual basis than any other household survey. The image on this slide shows some of the geographies for which ACS data are produced and the relationship between them. Lower geographic areas fit neatly within the larger areas directly connected with lines. For example, school, congressional, and state legislative districts fit neatly within states and do not cross state boundaries. However, they may cross boundaries of counties or metropolitan areas. In this visualization, you can also see the smallest geographic building block is the block group. The ACS's unique ability to report on a wide range of geographies is what gives it such a broad appeal. Joshua will go into more detail about some of these geographies during his portion of the presentation. Covering a wide range of geographic areas, ACS data are most commonly needed at the state, county, place, census tract, and block group geographic levels. This slide illustrates the relationship between these common geographic types and how they are nested within one another, as this example shows in El Paso, Texas. Census tracts are small statistical subdivisions within a county with populations of about 1,200 to 8,000 people. Think small towns, rural areas, neighborhoods. Block groups are a group of blocks within a census tract with about 600 to 3,000 people, as you see blown out in the right corner of the screen. Again, ACS's unique ability to report on a wide range of geographies is what gives it its broad appeal. If you're interested in learning more about the latest available geographic boundaries, the Geography Boundaries by Year webpage is a useful resource. It contains a list of geographic areas such as counties or tracts and the vintage they use for each year of the survey. Please note that the ACS plans to publish the updated boundaries for the public use microdata areas, or PUMAs, with the 2022 ACS data release. And we plan to publish the updated boundaries for zip code tabulation areas, or ZICTAs, with the 2021 ACS data release. The URL for this webpage is available at the bottom of the slide. These data products are released about 1 year after the data are collected. ACS data are generally released in September, the calendar year after collection, as 1-year estimates. In October, the calendar year after collection, as 1-year supplemental estimates. And 5-year estimates are generally released in December, the calendar year after collection. For example, the 1-year ACS data collected from January 1st through December 31st of 2019 were released in September 2020. ACS one-year estimates, which combine data collected over 12 months, are available for geographic areas with a population of 65,000 or more. ACS one-year supplemental estimates are a subset of the detail tables that are available for geographic areas with populations of 20,000 or more. They are simplified versions of popular ACS tables and provide the most current data to almost twice as many geographies as compared to the standard one-year release. ACS five-year estimates combine data collected over 60 months and are available for geographies of all sizes down to the census tract and block group level. The full detailed data release for each year is available on the link you see on the screen, which you can navigate to by visiting census.gov/ACS. The 2020 data release schedule looks a bit different from the standard schedule shown on this slide. Due to the impact of the COVID-19 pandemic on ACS data collection and data quality, we did not release our standard one-year ACS data products as planned. Instead, we released a set of experimental estimates from the one-year data. Additionally, the five-year estimates have been delayed until March 2022. Please see the data release page listed on this slide to learn more information and to see the current 2020 data release schedule. And now I will turn it over to our next presenter, Joshua Coutts. Joshua, the floor is yours.
Hi, Ryan. Thank you very much. That was very informative, and I just want to thank the audience for tuning in for our presentation. So we're going to speak about the tabulation geography, and tabulation being geography that we tabulate data for, specifically ACS today. I will just specifically say that we do have a wide variety of different geographies, for example, for the economic census, for the census of governments, and for various other surveys within the Census Bureau. And many of these different censuses and surveys have specific suite of geography that's applicable to them. And as Ryan made note of here, there are even some population thresholds and other controls that are put in place for the ACS in terms of the geography and their data releases, associated data releases. And another way to think about the different geography that we have, and one that's a frequent breakdown that we use in the geography division, is the difference between legal or administrative geography and statistical geography. And one of the important distinctions between these two geographies or types of geography are that legal administrative geographies are geographies that we, in collaboration with an external stakeholder, draw up the boundaries for these geographies. Specifically, we look to states to provide the Census Bureau with the legal state boundaries, counties the same. For cities, we reach out directly to the city, the county, or the state as applicable to receive the legal boundaries of that city. So we have an external source that we reference, that we rely on to provide us with these boundaries. On the statistical side, we have a bit more flexibility in terms of how these boundaries are drawn up. In large part, the Census Bureau will draw up the framework for how these geographies should be determined, for example, the regions and divisions of the U.S., and have various programs in which we have outreach with local data stakeholders and solicit requests or solicit input on how these geographies should be drawn up. For example, census tracts. Census tracts, we work with local planning officials, counties, states, and they provide us with input on the current census tract boundaries and provide any updates and requests for changes in the census tract boundaries. And the same for various other geographies. So again, the statistical side is where there is less external participation, where the Census Bureau is really in some respects, the controlling authority on how these geographies are drawn up. Can I have the next slide, please? And another concept to discuss with respect to census geography, the different nesting relationships. Ryan had a great example in Texas of how census tracts and block groups nest within a county, and different geographies that we have will have different nesting relationships. Sometimes they don't have relationships between them. In this case, again, we are showing the county and census tract and block group relationships. Again, the smallest geography that the Census Bureau produces data for is the census block. We frequently get questions about ACS data for census blocks, and to reiterate Ryan's point, ACS does not put out data for census blocks. The block group is the smallest unit. So even though there are tabulation census blocks available, that's only for decennial data, only for census data, not for the ACS. Next slide, please. And so while there are some nesting relationships, such as the relationship between counties and census tracts, where this is an enforced relationship, where the definition of a census tract, they are defined as being within a single county. So we'll never have a census tract that straddles two counties or is in multiple counties. There is also enough flexibility for local officials and local data stakeholders to define census tract and sometimes other geography, to define those census tracts to nest within another given geography. In this case, in our example here, Souderton, Pennsylvania is a small incorporated place where you can see the incorporated place in pink, and in the purple outline, if you can make that out, there are two census tracts, and that was specifically designed by the local stakeholders that they wanted to be able to get census tract data specifically for the northern and southern portion of the city. You can also make out there's some red block groups within those. Again, the block groups nest within census tracts. We have a multi-layer relationship here between these different geographies. So you can really slice and dice this data down into individual portions of the neighborhood. Can I have the next slide, please? But this doesn't always have to be the case. So there are lots of examples where the census tract does not have a relationship with incorporated places or other geography. In this example here, the thick line down the horizontal line is actually the county boundary. So we can get a couple different things here. Is the cities can straddle county boundaries. So this Imperial city in the north actually crosses into two different counties. That's perfectly fine. And El Centro in the south is entirely within one county, but you can see that there are multiple census tracts that it has a relationship with. One of the reasons that we draw these distinctions and draw your attention to these types of relationships is that when you're downloading ACS data, there are different summary levels, there are different aggregations of geography, and how the data is presented for those different aggregations of geography can make an impact on the data that you get. So keeping in mind these different relationships, the different summary levels, when you're pulling the data, you can get very fine relationship parts in your data products, in the reports you're able to receive from the Census Bureau. Can I have the next slide, please? A frequent question that we do get is, can I get a list of all the census tracts and all their related data that are within X city, or can I get a list of all the block groups that are in this example, El Centro? And we want to make sure that people understand that there is not necessarily a relationship between these different geographies. Again, there are some geographies, again, in our example that we were calling back to, counties and tracts, that there is a relationship there. But in this case, between cities and tracts, there is not necessarily, and in this case, block groups. You can see that even the block groups and incorporated places in this example don't have a one-to-one relationship. So there are many block groups here that are partially in the city and partially outside of the city, And some of these block groups are even have a relationship with both cities, Imperial and El Centro. Next slide, please. So in this example, we were looking at 3 cities. We had El Centro, Souderton, and Imperial, and those are all classified as places, and more specifically, incorporated places. So the term places in geography is referring to basically communities, cities, towns, villages, an aggregation or concentration of population and housing in a discrete area, so in a specific area. We have 2 different types. Again, we have legally bounded entity. Again, that's incorporated place. These have the ability to, or the opportunity to get updated every year to boundary and annexation survey. So that's where we reach out to these localities, to these cities, these incorporated places, and request any potential updates that may have happened in the previous year: annexations, de-annexations, name changes, merges with a neighboring city, and the state, county, or local city officials can report in any of these changes to us. We'll get that updated, and you'll see those in updated ACS data as that's available. We also have a second type of geography. It's called the census designated place. It's also considered a place, but it's a statistical entity. Depending on the state, there's some states where it's very easy for a place, a community to incorporate. Some states have a lot of restrictions on the necessary regulations, the jurisdictional requirements for a place incorporating. So there are different regions in the U.S. where there are more or less incorporated places, but obviously communities exist all throughout the nation. And so census designated places were designated some years back, recognized in order to recognize those communities that exist on the landscape but don't necessarily have a legal framework or legal establishment, legal recognition with the state. Next slide, please. Okay, so we should be on slide 18 at this point, and one of the just concepts to draw with places, again, is that places are mutually exclusive, that one place cannot overlap another place. We'll often get requests for neighborhoods or municipalities as a data product. People want data for a specific neighborhood within a city. That would be, in our framework, that would be considered a separate place. So we don't have the existence of 2 cities overlapping. Similarly, we don't have the instance of a census designated place within an incorporated place, or 2 census designated places overlapping. For places, they're mutually exclusive. They do not overlap. And the other concept with census places are that these places are organic, meaning that they can expand, they can annex more territory, or they can shrink, they can de-annex, they can shrink over time. And year to year, these places can change in extent. I mentioned the boundary and annexation survey for incorporated places. For census designated places, they are on a decennial cycle. There's a large program, the Participant Statistical Areas Program, where they can report any changes. And again, they have the opportunity to change over time. And also the idea that these places represent communities, that we have different types of geography for different modeling, different types of processes on the landscape, and places are intended to represent communities, such that when you're on the landscape and someone asks, what is the place that you're in, that you would have a response in terms of the name of that area, and see landmarks on the landscape representing those. If we can go to the next slide of the nice purple and green map, we can get a good feeling for this distribution of incorporated places and census designated places. This is 2010 data, and we will be issuing updated 2020 map. It's not quite out yet. We're still wrapping our publications up, but you can see pretty clearly the regional distribution between places, with legal places and statistical places. Again, the incorporated place, the legal places, and the green census designated places where, for whatever reason, the state or local ordinances may discourage or put up roadblocks for places to fully incorporate. All right. So let's get the next slide. County subdivisions, and we can start talking about the next level of geography. So county subdivisions are literally what it sounds like. They're subdivisions within a county. So they are subunits, they are divisions within a single county. So we, again, as with places, we have two different flavors of subdivisions. We have a legal, bounded, generally stable, minor civil division, and then we've got statistical census county divisions, CCDs. These are defined within a single county, and they divide up that county. They exist, minor civil divisions, the legal variety exists in about 29 states, District of Columbia, Puerto Rico, and island areas. And they generally have a formal government with elected officials, but the real defining point of minor civil divisions is there is some legal definition of them. They're often referred to as townships, charter townships. Sometimes they're called districts. A lot of it depends on the state and the legal framework within the state. CCDs are, on the other hand, statistical geography, and they're drawn up, again, through the Participant Statistical Areas Program. Again, that's every 10 years in preparation for the decennial census. And although they are used, of course, for ACS reporting. So these are sub-county units with stable boundaries and recognizable names. We work with local data stakeholders, again, with county, state, regional planning associations to provide us boundaries that make sense locally, that we can produce data for those geographies. And if we go to the next slide, we can see the regional distribution of these county subdivisions. And on our map, you can see the strong green color there, and those are where the CCDs, the statistical county divisions, are located. And in the various shades of purple and lavender, you can see these are where MCDs, the minor civil divisions. I'll call out specifically the dark purple there, and those are where we call them functioning MCDs and the strong MCD states. And those are states where the primary focus of local power, local governance, is at this MCD level, at the town or township level. Counties frequently don't have a lot of power. Most of that local governmental power has been devolved down to these towns and townships. The different shades of pink and lavender indicate kind of the level of governmental function that these MCDs have. In the very light pink, a lot of these don't have very much governmental function, but there's a legal definition of these types of entities that we can use at the county level. So subdivisions of the counties legally described with the state that we can use for producing data. So we'll go ahead and do that, even though they don't necessarily have much actual function. And if we look at the next slide, I want to also just again get back to that concept of the relationships between these different geographies and different entities. And we see here the relationship between places and county subdivisions as two separate types of entities. In this example here, we can see the very regular shaped square geography, these townships, and that's referring to the MCDs. So those are the minor civil divisions, again, the county subdivisions. They're legally described, and generally we can think of these as providing administrative and governmental functions for a given piece of area, for a given land area. Whereas the places, again, as I noted, places are more focused on a specific community, development, settlement, concentration of people, and associated functions. So as we can see, right in the top middle there, Sparta Township, there's a township called Sparta. It's the big square there up on top. And within Sparta, there's an incorporated place. There's a city called Sparta. So these two are not the same thing. They have different governmental functions, different powers. In some cases, cities, places will take on the function of the MCD as well as the incorporated place functions. And so as we can see just to the east there in Rockford, Rockford has actually taken on the function of the county subdivision and the local city functions. So they've consolidated those two functions within one civil government. But that's not always the case, as we can see in some of the other examples, again, in Sparta, where they independently operate at the MCD, the township level, and the city level. They have two functioning separate governments. The light orange colors are the census-designated places. Again, these are local communities, concentrations of population, commercial functions, and while they don't have a legal description, they have no legal authority within the state or the county. They are concentrations of population. They are communities. They're recognized communities locally, and we want to make sure that we can provide data for those communities by creating these census-designated places, which then allow us to aggregate data in that area for that CDP and provide data out. And if we can have the next slide about geographic boundary updates, I wanted to tie some of the pieces together that I've been mentioning about geographic boundary updates and where we get these boundaries from. And again, to reiterate that we have, we can think of these as just two sources of boundary updates, and one is internal and the other is external. Internal to the Census Bureau, external meaning our external partners at the state, county, local, tribal, or other levels. In some cases, it'll be other federal partners who work with us to provide boundaries that we then use in our system. So for our external example, I wanted to talk briefly about something I mentioned already, the Boundary and Annexation Survey, and we may talk a bit about school districts as well, as being an example of where we are working with external stakeholders to collect boundaries and make updates. The other example would be the zip code tabulation areas. I know that is often a confusing geography, and urban areas, if we have some time for urban areas, to talk about ones that are pretty much developed internally with very little external input. And on the next slide, I've got a list of the different geographic update programs, just as a bit of information there. Many of these are done prior to the decennial census. Some are done post-decennial census. Many of these are done every year. The decennial census for the geography division is a big milestone for us. And then we, again, maintain various geographies over the time period. Some of these, I wanted to call out specifically the post-decennial census geography because we actually use the decennial population and housing counts as inputs for these geographies that are highlighted here. Zip code tabulation area, we're using zip codes that are attached to housing units in the address file that we develop through our census work. So by the time you have gotten your census form in the mail, we've already gotten that address, and we've got the zip code that's attached to that address. And so we use that zip code in that list of addresses as input for this. Does urban areas use population and housing data that we collect during the census? As with PUMAs, there are various population thresholds that the PUMA uses, and their population thresholds based on the decennial census, and as well the congressional district and state legislative district updates, redistricting, are based on population counts that we collect during the census. In the next slide, we will take a look at the BAS, and we'll give just a brief overview on the BAS program. And that is the annual opportunity for the tribal, state, and local governments to submit boundary changes, annexations, de-annexations to the Census Bureau. We collect those and make updates. Again, that's every year. Those are then provided to the ACS for their data needs and reporting. Starting this year, we'll also have the opportunity to make updates to census-designated places boundaries through the Boundary and Annexation Survey. On the next slide, the BAS participation eligible governments, we have a list of federally recognized tribes, counties or county equivalents, minor civil divisions, and incorporated places. And if you remember from previous, earlier in the presentation, these are all legal entities, and they're legal geographies that get updated through the BAS. So it's legal governments that we reach out to. The next slide is the BAS response methods, and that's a digital exchange. So we have moved away from paper-based operations. We're looking in the future to going full web-based, but for the moment, we have GUPS software, the Geographic Update Partnership software. It's an open source QGIS-based software that we've developed in-house at the Census Bureau. We provide that to our data stakeholders, so our partners at the state, local, tribal levels, to make their updates to boundaries using the software, and they ship it back to us digitally. It's a really smooth process. But again, we're hoping that by 2030, one of the goals is at some point we will move entirely to a web-based exchange. So people just log into a browser and do this work. We've all got our fingers crossed. We're looking forward to it at the Census Bureau. And again, just the next slide for the BAS boundary updates, just a graphic showing an example of a boundary update that we would receive, for example, during one of our BAS programs. So you can see in blue, for example, the incorporated place, and the red with the yellow boundary outline. That would be an example of a request that we would get from that place or locality there to update their boundary. And so that would be an example of a legal boundary change, again, working with an external partner. The next slide, I want to cover the zip code tabulation areas. To discuss a bit about the zip code tabulation areas. Again, we consider this an internal program and a statistical geography rather than the legal geography. We're just looking at the legal updates. Zip code tabulation areas are approximations of the distribution of zip codes based on the data that we have collected in the field. So based on our internal geography, the master address file that we have in the geography division with all of the housing units that we've reached out to during the census, during the decennial census, and looking at the zip codes attached to them. In the example that we can see here, they're based at the block level, and it's based on the most frequently occurring zip code for each block. So each census block is reviewed it's determined what the most frequently occurring zip code is for that block, and then that zip code is attached to that block, and then at that point called a ZICTA, zip code tabulation area, which are then, the blocks are then aggregated up into larger areas and produce the zip code tabulation area files that we use to produce our geospatial files and the statistical data such as the ACS and decennial data. On the next slide, just another visual of just kind of how this works. Zip code tabulation areas, we get a lot of questions of these, and I hopefully this graphic answers some of the kinds of questions that we frequently get. We start with census blocks. The slide in the middle, you can see each dot is representing a housing unit, and each color of the dot is representing a unique zip code that's attached to that housing unit. In the final slide there, you can see how we have determined the most frequently occurring zip code in each block, and then have created zip code tabulation areas that represent the majority zip code within the area represented there in that aggregation. We'll go through the entire nation and make those determinations again, block by block, aggregating them up. I think that's the end of my presentation. I really appreciate everybody's time and attention. I think there's questions being answered in the chat, and we'll be happy to continue to do so. Thank you for your time. I'm going to turn it over to my colleague. Michael is going to speak to you about geographic products. Thank you, everyone.
Thank you, Josh, for that. That was a wonderful presentation about the geographies that we work for Tabulation Geography. Good afternoon, everyone. I'm Michael Arthur, a geographer in the Geography Division. I'll be going over geographic products and how they can be used with ACS data. One of our most common geographic products with ACS data is the geodatabase with the 5-year estimates. These geodatabases bring together geography from the Tigerline shapefiles and data from the ACS 5-year estimates. The example shown here on the slide shows census tracts for the state of Maryland. Common tables that users join to geography are age and sex, race, and income. By joining the data to the geography, a thematic map can be easily created. In the example here shown, this shows age and sex table has been joined to the shapefile. And then the attribute table that's shown in the background there, that top line that's highlighted in the light blue, that's showing a census tract. And in that second column from the left, that's titled B01001E1, that's showing the estimate for the population for that census tract. So it would be 2,273. If you look at the header, it's not intuitive what it represents. And that's the reason within the geodatabase file, there's a metadata table that can be opened. And if you look at the screenshot there of the GIS software and the layers, you can see that I have added the metadata table that can be opened and view what field you're looking at. The third column from the left there, that B01001M1, that represents the margin of error. And again, by taking a look at the metadata table that's part of the geodatabase, you can better understand what each field represents. At the moment, data.census.gov does not offer an address search feature. A geographic product that does is called the Census Geocoder tool. This tool allows a user to enter an address and then find geographies that correspond with the address. For example, a user would enter an address, then receive back the county, subdivision, tract, and block the address is located in. Once the user knows the geography they are looking for, they can go back to data.census.gov and look up the ACS data that corresponds to the geography. Another popular function of the Census Geocoder is the batch geocoding. This is where users can submit up to 10,000 records and receive back the state, county, tract, and block in a CSV file. Not all data users are familiar with Geographic Information System, also known as GIS software. That is why the Geography Division created an interactive map that can run from your web browser called TigerWeb. This application allows users to zoom into an area of interest and turn on and off different layers of geography. Located on the left-hand side of the application are the geographic layers with boxes to check on and off different layers of geography. The example shown on the slide is Washington, Pennsylvania, with incorporated areas shaded in red. Just to the south of Washington, you'll see North Franklin Township with the black solid line showing the boundary of the township. As Josh mentioned earlier, townships are also known as county subdivisions. And I'll draw your attention here to the left-hand side of the layers there. The two most common layers that are turned on is the transportation layer, which shows roads and railroads, and that'll be your second box down. Let's say that you're looking for ACS data for your local neighborhood. So turning on this transportation layer will allow you to zoom in. Maybe you'll find a nearby interstate or a highway that will help you narrow down your search, and maybe a nearby major street. And then the second one would be the census tracts and blocks. That would be another great tool to turn on so you can identify the geographic location that you want to obtain ACS data for. So some of our upcoming geographic products, the zip code tabulation area products, just recently, the relationship files are now available on the census.gov website, and our ZICTA shape files will be available first quarter of 2022. Our urban areas will be available late summer of this year, as well as the public use microdata area will be available later this summer. And just to clarify, the ACS data for ZICTAs, urban areas, and PUMAs will be released at a different time than the geography. And with that, I'll toss it back to Ryan to talk about additional ACS resources.
Thank you, Joshua and Michael, for those informative presentations. Now I'll conclude by briefly talking about the variety of resources the Census Bureau provides for learning more about our data, tools, and about the survey at large. First, we have the ACS main page, which is a great tool to start with if you have questions about ACS. This page can be found by going to census.gov, selecting surveys/programs, and then ACS, or simply go to census.gov/ACS. The American Community Survey website contains a lot of information about the survey, data products, tools for data users, and other helpful information. We have data user handbooks available on the address on the slide. These recently updated handbooks are provided in PDF format and are downloadable. Each handbook is directed towards a specific audience and contains how-to instructions on using data in different ways for different reasons. Each handbook also contains case studies showing actual instances of how the American Community Survey data was used by the specified audience of the handbook. As you can see from the list of available handbooks, there is one dedicated exclusively to geography. As I wrap up today's webinar, I invite you to stay in touch by telling us how you use data from the American Community Survey. For example, have you or your organization used the ACS to make an important decision, help your community, or expand your business? If so, please visit the link at the bottom of the slide to share your story and explore how data enthusiasts across the country are using ACS data in creative ways. Doing so provides further support for the importance of the data we collect here at the Census Bureau, and is a great way to further promote our data. In closing, I encourage you to connect with us directly. You can reach out to either the American Community Survey Office or the Geography Division by phone or by email at the contact information listed on this slide. You can also visit our respective websites, census.gov/ACS and census.gov/GEO, to learn more about each topic. And with that, I want to thank all of you for joining us on this webinar today. Again, a recording of today's webinar, along with the slides and a transcript, will be posted online shortly. This concludes the webinar. I hope you have a great day.